Bow, bow.
I'll start from the top.
So give me a couple more seconds.
Cover slide disappeared. So.
All right, Denilson, whenever you're ready.
Okay. My cover slide disappeared, so I'll start straight from the about me. So my name is Denise Anastasio. I'm a developer advocate with IBM. And you can see my links to the right if you want to contact me later. So on the personal side, father of 3 boys, had a business in education in the past, been little league soccer coach for a few years, very rewarding. Backyard farmer, love it. Getting into a bit of the profession. Oh, I forgot had a picture of my dog. I'm a master inventor. That's by title. That's long program here. If you Google me, that's probably the kind of thing you're going to find in terms of I have around 30 patents with patent office here in Europe. My previous work before development advocacy, I did visualization and business intelligence for cancer research. Left the link in there if anyone wants to take a look. Very cool work. I think one of the best phases of professional non-cloud types of work in my life. Very good. You can tell, some people recognize Saitama, big fan, love the genre. And eventually, now and then, I go to my other non-technical blog, and you can visit me there and see kind of things I write about. So getting started with our program, I divided it in 3 parts. So when we are talking about distributed tracing, I want to talk a bit about service meshes because it goes very well with that subject. So split it in 3, so some concept, then get into some of how to instrument the code in the cheapest way possible. And the visualization shows some of the tooling around this, give people some idea. I have a live demo ready if we have time, so just show some screenshots, but if we have time, we get to see some of this live, which is pretty cool. We get to show a command line, and then I believe I lost the link. All right, so getting into it. As I said, 3 parts: introduction, microservices, right? I don't know. I get the sense that this crowd here is a fan of it, depending on who you talk to. I'm not trying to convince anyone about it, just saying where it could be useful. I think everyone knows the pattern. You want to build the train station, project manager comes in and lines up all the little tasks, the Gantt chart, and what goes where. Even if you're doing Agile, you know how it works. A Friday afternoon could be a weekly or bi-weekly sprint. It comes in and it does this to your schedule. You get the people trying to do documentation, the people trying to do testing. There is always that last activity that doesn't get as well done as we'd like. So that's a big why. So instead of your train station on that Friday, you get parts of the track, a lot of things laying around ready to be built, but it's not quite what you wanted. And there are other reasons too. I mean, I was talking about scheduling. I think that's the most blatant one. There are very good reasons in terms of scaling. You get into the cloud world where you cannot scale your whole system and create clones of it. Sometimes just portions of it make sense. But I'm focusing more not only on the scheduling side of it, where these things have to be done at a certain time, but also that aspect of everything having to be deployed at once, right? And then if you're not doing microservices, there is that big day of delivery. Whoever gets done early has to wait until their next deployment opportunity. And then they find out on Monday that there is the one thing they actually needed, and then you get your Monday deployment. I think everyone knows the drill, the horror story, right? So when you hit a wall, you focus on one break, right? You get that Friday afternoon out of the equation, and every team gets its own delivery date. Make some things better. I mean, the idea of everyone getting the release date is a bit daunting. But if you do it properly, if you bring your manuals and your brick adapters, and each of these projects is run individually, consistently, your tests your validations, your APIs, right? Your quick adapters, your APIs are well documented, well managed. It's a much better situation to be in. It does feel like added cost, and that's not the focus of the presentation today. I could go into the fire chat mode of the horror stories of the monolith, where it sounds good if you don't look hard, right? So moving on, and the idea here is that I don't want people to try and read through this, but it is the landscape. When you get into the space of microservices, and I didn't even try to zoom it out to a point where you can read this, but you have a lot of the deployment stuff on the left, on the upper left. Is your provisioning, your service meshes, your CI/CD tooling, your deployment tooling, your protocols, databases, all these interesting things. And I do encourage people to go look at it. I think there's probably like half a dozen meetups hidden in this picture, if not more. But for today, I'm going to zoom in into what we want to talk about. So we're going to be talking a little about the service mesh and much more about the observability and analysis portion. So I put a blue arrow next to the tools we'll cover. So hopefully we'll have a couple minutes for each, mostly on the right. I know there are more arrows on the observability block. Istio does a lot of the heavy lifting for this. If you haven't checked out technology, and I have the links for it later, very good thing to get into. Either Istio or Linkerd, but worth a look, spending a few minutes on service meshes. So when you get into observability and analysis, I had this very good coworker. He was 60 years old, more experienced than everyone in the rooms where he would mentor us combined, and he took us always through this what's and when's and how's and who's. So he always had this method for finding out what was wrong. So if things were working, when it started, the frequency of those things, the location, the extent of the impact, and also these are all the monitoring tools. And I'll cover a couple of them. So Kiali and Grafana will do that. We'll see a bit of how that works and how that lines up with tracing. I'm not covering logging today. Love the space, but I think deserves its own meetup, I guess, its own presentation. You know the funny phrases on the left, right? My favorite is, and these are all real. These are from real products. My favorite is the second, of course. For people who understand, the third one is a famous event last year. I think you may know. Southeast region is gone. But I mean, you're looking for what to go search on Stack Overflow and Server Exchange, Stack Exchange. I mean, these messages. I mean, it's an interesting topic. Skipping that today, I wish I had another 30 minutes to weave into the discussion. And then the tracing portion, which I think is the core of the talk or the main takeaway. We wanna, once we get past the monitoring part, where we know what is not working and where, we want to see more, right? We want to understand what is disconnected, why is it taking so long, this is not even connected at all, what it used to look like before and after and all. Pretty hard to do with all the kind of tooling we are about to cover. Haven't seen anyone do this right in a monolith to date. I've been doing this a long time. All right, so getting into the real content or the concrete content, right? Before talking about distributed tracing, we need to understand the data model. Open tracing is the de facto standard today, and you can. I have links later. You can check this link on the specification. I'll be posting the slides. Open telemetry is supersetting, sunsetting open tracing. I think open tracing is being merged with open census into that. I don't have good material for it yet. A lot of that is still under development. So open tracing is the focus today, but a lot of this applies to open telemetry as well. So there are, I think I'll cover 3 or 4 concepts here. Collection of spans. On a trace, it's a collection of spans, which I'm about to show. Essentially, it's not just a collection, it's a graph of spans. A span contains another span and so on. So imagine just a tree of them. And you will map them loosely to a business transaction. So you have something that says, complete an order. That's the kind of thing you want to trace. If that's going to go rippling through 3-4 different systems, that's probably what you want to call trace. It's pretty arbitrary, but map it that way. Just if I take this small microservice architecture as an example, which we'll use later, then I can talk about spans. What is a span? It's just an operation name, start and finish timestamp, some tags, optional. You can log content, just free-format text with a span. There's a bit of baggage items. I'll cover that in a moment. So it's pretty much, if you couldn't fit any information you needed in a tag or a log, and you just had some free-format structure, like some JSON payload that you needed to log with the trace, that's a baggage item. And the references to other spans. The picture is forming, will make sense in a moment. The references. So if you have multiple spans, and now you see all of this coming together. You have a trace, again, arbitrarily mapped to a business operation, like quote an item. And the microservice A could log a span, just decide arbitrary again, could be at the beginning, at the end of a transaction. I'll have some span, name it quote item as a start and end time. And once the calls get to, say, microservice B, the service B could decide on creating multiple spans to represent whatever it's doing. Could be the part where it does some processing, could be the moment where it's calling a database, completely arbitrary. You can just, the application may be choosing to generate multiple of those. And you see the whole picture, right? Whenever someone calls quote item, a structure like this would be sent to a tracing server. And if you look at them as a matter of time, you would see that quote item would take longer than its subcomponents. And you would see, and I have a nice screenshot of this on Jaeger later, where you see a very deep tree of who called who at which point, how much time it took for one call to happen and for it to actually start to be processed and so on. But that's the concept. And then we get to the flip side, not flip side, but the complementary side of this. Because if you're going to do tracing, you probably want to be doing monitoring first, otherwise you don't even know what you should be tracing. And Istio injection is something that I fell in love with a couple months ago. If you have your microservices like in the previous slide, you don't need to go and even modify your code. In fact, I didn't modify any of the code, seeing that I hope to live demo in a moment, waving here to my sensor. So the idea with Istio is you tell it to just intercept all the communication between, to inject itself in the communication between these components. And it will do things like ingress handling, so routing, security, whether certain calls are allowed, could be by header, payload content, so all sorts of interesting inbound traffic control. So that's the connection, security, and control part of it. On the control part, for instance, if you could decide that 30% of the traffic have to go to a certain region. We're talking about microservices where maybe you deployed version 2 of a component and you just you want to do a feature flag and you just want that version 2 to take in and say 10% of the traffic before you commit to rolling out the entire content to the new version. So your deployments are not as frightening. But today the focus is really on that observation part. So Istio will interject itself into all the conversations across components and allow you to do very interesting things with that traffic. And we'll cover some of that. Not only to do something with the traffic, but also to watch what's going on. I said this is a polyglot approach. I want to show kind of the level of difficulty on the feel of the mainstream frameworks there. I wanted to have Rust and Go and many others, but these are the three where I think the heavy hitters on business code today. I think Go and Rust, love Rust, and others, but maybe they're not the kind of things where you would be writing in like an end user application and others, or maybe not the most common right now. So these three, I'll go back to my 3 service example. So we'll start with the Istio traffic first. all the traffic after the Istio injection will go to the Prometheus database, and we'll take a look a bit at Grafana and Kiali and what it can do with that data. And then we move on to the tracing part, where you'll see that open tracing traffic going to a Jaeger backend and see what it looks like on the Jaeger UI. The injection, pretty simple, dead simple. You have two options. Either you, after you install Istio, or assuming, if you're using Kubernetes and you have already deployed Istio to that cluster, you can say just that you want Istio injection enabled per namespace. Anything that gets deployed in that namespace gets it. You still have to declare a couple things in there, because if you make it before the namespace, there may be some application where you don't want it. So you have this flag, this annotation where you can set it to true or false. In these examples, you will see everything is true. The labels. Labels are important, kind of optional, but really important. So better do it always. Some of the UIs, you'll see why that is. The version is a given, right? Talking about microservices, if you want to do your progressive role feature flags, and now you definitely understand why you need a version. That's that option. Second option, maybe you cannot do this by workspace, or you already have applications, you don't have the YAML or don't have control of it, of your deployment. It's an after the fact deployment. You just find the deployment and tell Istio to inject itself or inject its sidecars into that deployment. So it will do things to the deployment manifest. It will not be permanent. If you deploy again with that YAML, the original YAML, that injection will disappear, but it's an option. If it is not a deployment under your control, the second version here will get it done. I'm prone to the first. Node, how you do this in Node? Pretty simple. You're going to touch two files. I have an example of the three there. And so you would just something quickly. Your Node.js file and your package. So dependency is pretty simple, Jaeger client and open tracing. And in that, your Node.js was probably the hardest of the three. I think Java has its own verbosity, and Node is more, it starts faster and all this, plenty of advantages. But the instrumentation was kind of heavy. I mean, you look at all the packages you need to bring in, the initialization, a lot of boilerplate, at least on the initialization. But once you get past that, you're just going to be using that tracer variable everywhere in the code. Once you have a request, and this is Node.js Express, there are these things you always need to do. So you need to extract the headers coming into the request. We're talking about spans. You're going to declare the beginning of that span. You may say that is a child of the incoming span. Typically, you will do that. You could have an option of logging some message in that span. You will do your business logic and finally complete that span. And I have source code that shows a bit more of that in the outbound call. Okay. Spring Boot, right? Very popular Java framework. If you've done Spring Boot, you recognize the dependencies in your XML. There are 3 of them to be done. I didn't put the versions in there. Whenever you're ready to do this, just pick the one that's the latest, I guess. I do have a Git repo that I'll mention later that has all of the working code for this. Once you get your dependencies in, there's a bit of boilerplate in the main of your Spring Boot. Pretty simple, right? Just one line, just an injection of a bean in declaring that your tracer that is initialized. There are options when you look at that from environment. You could add certain things to that configuration, sampling, and a number of things, but not covering them here. The link that I'll mention later has a nice tutorial style documentation that contains step-by-step on how you would rebuild this application if you wanted to. Just getting the essentials here. And once you get into the code, looks a bit heavier than I would like, but that's how you would get the spans from the inbound call. You can see that build span call that's starting to create a child span from the incoming You see the S child of call, so essentially declaring that, if you remember the previous examples, the child of that parent, that incoming, that wrapper master span, you would do whatever business logic you had to do. You maybe would have set an error if something happened, and then finish that span. You could create as many as you wanted at this point. Next one, probably the slowest to run because it's a heavy framework, but also the easiest to code. This is JEE, is using Open Liberty. So it goes with the dependency is just one. I have the blog entry from where I just extracted this. Pretty simple in terms of legwork to be done. You have just to include the open tracing feature into your server XML. If you've done Open Liberty, you recognize this file. And in terms of your code, there is no need for initialization. And you see there's less boilerplate. It does a lot for you because of that combination of microprofile and open tracing. The amount of boilerplate is pretty minimal, right? And if you don't want to create your spans, you even get the spans out of the parent method for free, and we'll see that too. So to me, out of the three, I mean, you can see here in terms of volume, the easiest to get instrumented. Let's look at those visualizations. Grafana. Grafana is where things start, right? You just remember I said what is working, what is not working, and how bad it is. So you see, I don't know if you can see it, maybe this the live demo it will be clear, but this is just a count of HTTP response codes by service, and that confusion on the right, the kind of things that don't look good, those are the 503, the gateway errors and all. I simulated that failure. So Grafana will allow you to do charts, individual charts, dashboards. They can be shared in JSON. I have the JSON for this dashboard I'm about to show in that repo, the one backing the whole code, the tutorial. I'll show you in the end. Query language is an acquired taste. Probably you couple days you could spend learning, reading through every single function in there. I can't say that the syntax is the most obvious, but lots of good samples there. So I was able to build this in less than an hour from scratch. What you see here, just nice gauges about which service and the count of response codes per service, and also that temporal view of how those errors came about. Right? Istio itself ships a number of dashboards, and I hope I'll get to some of them. So, I mean, you get the idea, right? And from that pyramid I showed at the beginning, Grafana is the one that shows you what is not working, how bad it is, and that gives you an idea where to go next. Kiali is also a monitoring tool in a way, but it's much more detailed, right? It's going to show you the little check marks, your applications, your workloads, and with the green or yellow, and tell you that there is a problem somewhere, whether things are healthy or not. You start to see that those labels I mentioned on the deployment YAML being mapped to Kiali. We show them as workloads. So if you want to have some meaningful name to your application, or you want to see all of them, that's how they would get mapped. And you get to see the health. Like I said, it's a bit of monitoring, but maybe too detailed. You probably wanted to have started from Grafana before telling someone to go and find out the system state from something like Kiali. Then you have these nice views. These are fantastic, and this comes from Istio traffic injection. No code instrumentation whatsoever. It's just Istio looking at the traffic and say who's talking to who. You see a bit on the right. You have some statistics about incoming, outgoing traffic, the amount of errors, and those sorts of things. So you start to get a much nicer view. And I'll get to the live demo, I hope, where you can see this is actually animated even. It's pretty cool. Istio will do its fantastic code injection as well, so this is pretty cool as well. So you don't need to crash your app, or wait for it to crash before you learn about how it behaves. You can do these interesting things like injecting faults into the system periodic. Like this one I said, return a 502, a gateway error for 30% of the calls against the microservice B. I want to know if the caller service can be resilient to that, right? pretty interesting stuff that Istio will do and that you can observe with Kiali. And I showed after doing that gateway failure, you start to see Kiali showing things in yellowish. It starts to show a percentage of 500 errors in that traffic. That means that things are not going very well. But again, second layer of monitoring there, but that's very good insight into it. If we move forward, you would see the workloads. You would be able to see all of them. In this case, they were still healthy when I took the screenshot. And moving past that, Jaeger, I want to start talking about the distributed tracing. I have the snapshot of the topology we were talking about, and you get to see the service on the left. There's some searching for which type of traces. You would get the application names in there. It would show you a line, a block per trace, which spans were involved. And I showed this other slide, like just clicking in one of those traces, then you start to see the power. You see some of the Istio ingress in place. So Istio is telling you that it took part into that transaction, probably added a bit to it. It's showing its mixer component, making the decisions about routing. So pretty minimum, so pretty incredibly efficient when you look at overall transaction distribution. It shows the traffic coming through that Node.js application and then going into the JEE service, and you see also the time spent on each of them. And you also see, I found this interesting, and some of the debugging showed the reason where when the Node.js application makes its outbound call to the JEE application, there is a gap of 20 or 30 milliseconds where nothing seems to happen. And eventually I found out that this was just the JEE deserialization of the JSON payload, which seemed to be rather inefficient. But it starts to teach you more about your own code. That's pretty good. Troubleshooting, like I mentioned, you could inject faults. You could also inject, this is again Istio, you could inject delays, and you get to see the behaviors of your tracing before and after doing something like this. If I go back, now I start to see my calls to Spring Boot taking that, you see on the right that some of the ones to JEE taking 80 some milliseconds, the ones to Spring Boot taking a full second now because injected at fault. And now I look at one of these traces, that's this horrible gap on the call from Node to Spring Boot where something is dead in there. Right? I mean, I know in this case it's a simulated failure, but it shows you where you would just have a bit of a pause in there saying what's the service was working well, not now, where is that happening? And you see the overall business transactions now taking a second, and you get to see that's between that Node and Spring Boot call. Very, very apparent. So closing thoughts. Best practices for distributed tracing. I mentioned structure, so I'm talking about service names, span names, and tags. You want to be, you saw that these elements are used as searches, so you want to be careful about your names, not too general, not too specific. There are some good practices in there mentioned on the link at the bottom. Tags are good. Some standard tags out there, your organization may decide to have their own. Maybe it's the UI, or maybe you have some business organization, whatever way you want to classify your transactions outside of the standard tags. Good place to spend quite a bit of time, or maybe a bit of time with your team and your organization if you're doing microservices, multiple owners to agree on what those should be. Baggage, if you have certain things that you want to pass from, say, a UI to a backend and make maybe different decisions and some context that's passed around in these transactions, you could add those to the trace statements. They will be propagated from one service to the other. Timestamps. The libraries will add the wall time to beginning and end of the spans, but you have your choice. If you need some more precision, you can do that too. You can be very explicit about the timestamps to add. And if you're intermediating traffic from one application to the other, then it makes sense that these are part of the same business transaction. There are APIs on all those modules, all the tracer code for Node and the Java frameworks, and there are calls to extract the context from the headers of the HTTP headers of the incoming call, and also to adding them to the outbound headers to another call. If you don't do the injection and extraction, Istio will do for you, but the segments will all look fragmented. When you get on Jaeger, you're not going to see those nice stacks of one call wrapping another one. It's just going to look like a bunch of disparate segments. So that's what I had. Remember the takeaways. I hope I was able to give you a basic understanding, a desire to go look more into this. I find it a very exciting topic, especially if you're maintaining a production system or working in a DevOps manner, some sort of framework. I hope I gave you some concrete examples, and I'll give you an even more concrete example with the links at the end and the visualization as well. Next steps, deeper dive into open tracing. Go check it out. The complete source code for this demo right here. My great colleague, which I obscured his name, Carlos, who wrote this great tutorial where I learned a lot from him. His name will be in that link. Try Istio locally. Very easy. You can run that on most average computers. And if you can't, there is this great hosted system where you can have these guided tutorials and workshops where they'll just provision a cluster for you, open a prompt and a console where you can try a lot of the things I mentioned here today. So that's it for my presentation. If people have questions, now is the time.
Thank you, Denilson. Clap, clap, clap. Yes.
Hey, I got a question for you. So it looked like you were getting a lot of value in your traces coming from Istio, but I also saw that you were doing, you were injecting some of the libraries into your Spring Boot. But I'm not super familiar with Spring Boot. So can you just clarify, were you injecting that from a source code perspective, or were those configuration files? Because what I was wondering is, that's awesome if you're compiling this app and it's your own app, but what if you're also working with another service that you don't own? Are these tools something that you can use for services that you don't necessarily have the source code for, or aren't maybe compiling yourself?
Yes. If you don't have, I've seen libraries, I don't have them handy. There is the sort of this competitor to Jaeger called Zipkin. They had something that would be done at build time that would do binary injection to code. It takes a while. Probably you don't want to do that in a containerized environment if you're doing like microservices and provisioning things on the fly. But I haven't done it myself, but I know it's possible where you would start with a jar file and they would inject code in there. You probably have to instruct it where exactly, but I didn't hear great things about that instrumentation performance. Once this is instrumented, it will do the job, and maybe more verbose that maybe you would like, but it's possible.
Thanks.
Awesome. We have another question coming from Bug. What version of OCP is compatible with Istio?
Which version of what? Of
OCP is compatible with
OCP?
Istio.
Oh, okay. I've seen it as early as version 4. I haven't tried that with OCP 3, but all the versions of 4 should have it. I think, I mean, definitely for 3, which is the latest I tried, but I think anything above 4 or above would do it.
Cool. Does anybody else have any questions?
Do you have any like stories or anecdotes about big wins that you've gotten after you implemented this? Like there was some sort of repetitive issue that you fixed, or it helped during an outage or something like that? Or has this, how have you guys used this and gotten value out of it?
Not exactly this combo. This combo is pretty recent to me, and it's better than what I used to be. I used to be a big elk person, and before this job, that's when I worked with the oncology side. We had DevOps. We also managed the servers. The monolith side of it, we had outages where it was all hands on deck and half a day. And the joke was, the Dos Equis guy where it says, I never reboot servers, but when I do, it's during business hours. So the downtime, the instrument, this kind of instrumentation where you would get on a dashboard, and Kibana would do a combination of Grafana with logging, and you would get people zooming in into the real root cause in 30 seconds instead of an hour, and fewer people. So the idea is that first, it's not that you wait for it to happen when you can solve it faster, by all means, but also that you learn with it. I mean, just sitting in front of that Kiali dashboard, just in a sample like this, you already learn a lot. I'm not a big developer right now, but I'm a long time JEE developer. I had no idea that the JSON deserialization on an incoming payload was relatively that bad. It's not that I wouldn't stop using it, but I would use it with care. And then you put it side by side with something like Spring Boot, where the serialization allowed me to use multi-maps instead of a JSON object for a simple payload, and it was 3 times faster. And I only needed a field. So it's that kind of thing. So it's not just during a crash, but also during development. If you're in Kiali, let's see if I can bring Kiali on with the animation, and you get the feeling for it. I'm going to bring it to the other screen. I'm sorry if I'm looking up now, but I hope you can see. Right, I can't focus the screen there, but you see, you can have an idea of seeing that animation with a frequency of payload, the throughput, the delays, and everything. You get to learn a lot by your system. So just by knowing your system better, what talks to what and how they behave, and studying it before it crashes, it already make your eventual crashes that much less painful, right? You understand your system better. You know where to look for. You already have fixed certain things, right? So that's our the combination of new and old and new experience with it.
Awesome. So if we have no other questions, I'd like to move on to our next presenter. Does anybody have any other questions? We're good? Okay. All right. So we have Matt Ramirez. Thank you so much, Nelson, by the way. Clapping again. So next up, we have Matt Ramirez, and his presentation is on trunk-based development for beginners. So we're excited to hear your presentation, Matt.
Sweet. I'm excited to give it. Cool. Can you guys see my screen? Is that good?
Yes.
Cool. Alrighty, guys. So my name is Matthew Ramirez, and I'm a senior cloud engineer at Nebulaworks. So I guess professionally, what I do is I deploy environments for clients in the cloud, and I leverage infrastructure as code to do so. I also deploy container platforms in an automated fashion, both managed and unmanaged platforms. And all this is done with infrastructure as code and software development methodologies. So one of these methodologies that I use is the branching strategy that is trunk-based development. So this is a strategy that we use extensively here at Nebulaworks, as well as like in my personal life. And we find that it works wonders and it's pretty good. And our customers have found great success with it. So I thought I would present on it and fill you guys in on a pretty good branching strategy. And I guess like non-professionally, when I'm not working, I like doing things like rock climbing and hiking and badminton. So I like staying active. So, all right, so let's get into it. All right, cool. So as for the agenda, so today we're going to be talking about a couple things. We're going to be going over what branching strategies are, some Git concepts. We're going to be going over the trunk-based development workflow. And then at the end, we're just going to kind of summarize all of that and discuss the benefits that your team will be getting from leveraging the trunk-based development branching strategy. But before we get into that, I think it's kind of important that we talk about software development, because at its core, this talk is about software development, right? So the branching strategy and the release process that we're going to be going over today exists solely for the purpose of giving us a sane, efficient, and safe way to develop software in a team setting. So kind of just want to keep that in mind. And yeah, so let's kind of take a quick high-level view of software development. So the first thing that we're doing when we're developing software is we're developing new features, right? Functionality. So this could be bug fixes, getting like new functionality that you need into production, things like that. And then after we develop our functionality, we want to test it. So this can be done manually. This can be done via an automated CI system. You can run whatever builds and tests necessary to verify that your newly developed functionality works and that it won't break the build, or it won't cause chaos in your production environments. So, and lastly, we want to integrate this newly developed functionality and have it be consumed by our end users and leverage in our production environments. So hopefully, those three things are being done whilst leveraging a version control system, or VCS for short. So I'm sure many of you guys are familiar with the term, but basically, a version control system allows for developers to contribute to a code base in parallel and in a distributed manner. So again, this is where you store and version your code during the development process, and this is where you reference code for your production environments. So there are many version control systems out there: Git, Mercurial, TeamCity. There's many more, but for today we will be talking a bit about Git. So we repeat this process over and over again. It's a never-ending cycle. Software is never done. It can always be improved. And this is kind of like an oversimplification of the development process, but this is generally what's going on. So now that we kind of got that out of the way, let's talk about what branching strategies are. So again, assuming all the code that we're developing is stored in a version control system, we can make use of branching strategies. So at a high level, a branching strategy helps developers collaborate and develop new functionality while minimizing disruption to the existing code base. So almost all version control systems today support branches, or basically working in parallel. And depending on your flavor of version control, you may have a main branch that's called master, mainline, default, or trunk. The list goes on. But they're there to define a set of rules and conventions that specify when a developer should be where a developer should be branching from, where they should be merging to, and when they should be branching, just in general. So this is all needed so that we're developing code in a safe and efficient manner. So again, the branching strategy you use depends on your organization and team. There are a couple different flavors out there. You got things like trunk-based development, GitHub Flow, Git Flow. It just depends. There are some pros and cons for each one of those things. But today we're going to be talking about trunk-based development. Cool. So before we get into the actual workflow, I wanted to go over some Git concepts. So I chose Git because it is the industry open source standard for version control systems nowadays. So I'll be discussing the trunk-based development process as it pertains to Git. But in order to get the most out of this presentation, I think it would be beneficial to get a refresher on some Git concepts. So I'm going to be assuming you do, or you have used Git in the past. But it's going to be a quick overview. We're not going to be diving too deep. So the three Git concepts that we're going to be talking about are going to be Git commits, branches, and tags, because these are kind of central to the trunk-based development workflow. So let's talk about commits. So at a high level, you can think of a commit as a snapshot of the current state of the repository. So this is kind of oversimplified, but that's the general idea. So commits commits can come with associated metadata. So these include things. Let me put the pointer. Oh no, sorry guys. Let me put the pointer on here real quick. So these include things like, one, the name of the author or committer. These two can be different. Things like the date of the commit, as well as a description of what functionality is contained in the commit. And that last point I just mentioned is often overlooked, and it's super important for maintaining a clean code base, so what is actually being done in a specific commit. So commits also have relationships to other commits. So they can have parent commits, they can have relationships to more than one commit, for example, like a merge. And this relationship, this linking of commits, is how we get like what we know as history, or like a certain version of our code base. And last thing I did want to mention is that commits shouldn't be too large. They should encapsulate related functionality. And if you do feel like, you know, your feature is pretty big, a lot of times it's better to break it up into multiple commits, right? That way your code is more transparent and readable. So let's move on. Cool. So the next concept is a Git branch. So basically a Git branch is a reference to a specific commit, and that's about it. So what branches allow us to do is they allow developers to basically start off from a specific commit or a specific point in time of our repository, and then they can develop separate functionality from that starting position via subsequent commits. And so two developers can potentially branch out from one commit and develop completely different functionality, completely different commits without affecting one another. So eventually, when you have code being merged back into like a source branch, you may run into issues where there are conflicts because developers touch the same part of the code base, but these can be easily resolved, like resolving merge conflicts. So here we have a diagram that kind of shows, I guess, the history of a repository. So it's read from bottom to top. So basically here we have an initial commit. So this nodule, it's a commit. And this was like the first commit that initialized the repository with a README. So at this point in time, we have a developer, Betty, who wants to create a branch off a master. And at this point, she creates the branch. And now her branch, which is called branch 1, contains that initial commit. So she, is developing a really cool widget. So she has 2 commits because she wants to split up her feature into 2 separate commits. She develops it, tests it, and we're going to be talking more about testing in a sec, and eventually merges it back into master. So at this point, I didn't really include the extra commits, but our master branch has 4 commits. It has the initial commit that initialized the repo. It has both of Betty's commits, and then it has a merge commit. So at this point in time, master has 4 commits. So afterwards, we have our second developer, Mr. T, and he has branch number 2, and he branches from the point where, from Betty's merge commit. So at this point in time, Mr. T wants to leverage all of that new cool widget functionality that Betty has made. So he branches from that starting point. So now his branch, or branch 2, has the 4 commits that exist like thus far, and he can iterate from there. So that's the power of branches. They allow us to pick a specific point in time of our repository and iterate from there. So those are Git branches. All right. So next we're going to be talking about Git tags. So these are very similar to branches. So tags allow us to point to a specific point in time of our repository. And what's really cool about them is that they are, like, I'm going to call them conventionally immutable. So tags can be created, destroyed, and modified, but by convention, it's commonplace for teams to view tags as being immutable. So for example, once they're created, don't touch them. Like if you need to like add functionality like to our release or production environment, then you need to cut another tag and bump up the version. So I think in addition, I have a question. Oh, for sure. Yeah, I was going to talk about that a little bit more in depth. Yeah, thank you, Foot. Well, actually, I guess I wasn't going to talk about that in this this presentation, so in the Git world, but I will mention that real quick. So Flock brings up a good point that Git merge is also important to talk about. So basically what a merge does is it takes 2 commits and merges them together and then creates an additional commit that basically describes what happened, I believe. I think that's kind of like a very simple way to view it. But yeah, we can talk about that a little bit later. Yeah, cool. Alrighty. So, and actually it's also important to note that we make use of something called Git rebase as opposed to a merge most of the time. The only time that we're experiencing a merge is when we're merging branches back into master. But we'll talk more about that in a sec. Cool. So kind of continuing on with tags. So Git tags have two flavors. There's like annotated tags and non-annotated tags. So the only difference between the two of these things is that annotated tags will create an additional tag object in the Git repo. So this allows you to store, any information associated with the tag. So this could include things like release notes, a signature to verify like the commits, and leveraging annotated tags is very popular for open source projects. And as you can see here, I do have, oh, sorry guys. I do have this image here of a 0.1.0. And this is known as semver syntax. So basically the first digit 0 represents a major version, the 1 is a minor, and then the 0 is a patch. And so basically whenever you're cutting new tags, you will increment the version. And depending on the change or like the functionality introduced in the new release, the incrementation is going to be a little different, or the increment is going to be different. So usually when there's significant changes to the code base, so like you're changing like a lot of functionality or interface, you're going to want to bump up the major version. If the changes are kind of small, then you're going to want to bump up the minor. And if it's like a patch, like a bug fix, something like that, then you want to bump up that last digit, that 0. So yep, these are Git tags. Cool. So now that we kind of got that out of the way, let's actually dive into trunk-based development. And let's take a look at the workflow. All right, so as its name implies, trunk-based development has developers iterating on a single branch, and we usually call this the trunk. So in Git lingo, this trunk branch is known as the master branch. So this differs from other branching strategies like Git flow because there are like no long-lived branches where development takes place in. Another thing that's kind of I guess special or specific to trunk-based development is that master always has to be in a deployable state. So whenever we are developing functionality, maybe like at the end of the sprint, oh, sorry, this is, sorry, I just saw your comment, that was a question. But whenever you're adding new functionality, you're always going to want to make sure that master is working as expected. So let's kind of move on to, oh, here's the last thing. So releases are also cut off from master. So periodically, we're going to want to cut release branches. So basically, these are specific points in time of our Git repository where we feel comfortable with the code base. So we know, what, this works as expected. We're cool with this functionality being leveraged by our end users. So we're going to start the process of getting the functionality that's defined in master and start having that be consumed by our more stable environments, like staging and production. And we're going to be talking about that release process in a bit. Cool. So let's talk about how we actually develop new functionality in the trunk-based development workflow. So one thing that's very specific to, I guess, trunk-based development, and I know GitHub flow follows a similar paradigm, is that you have short-lived, I guess that all functionality is developed on short-lived feature branches. And these feature branches, or sorry, these new branches are branched off from master, and then they shouldn't last, more than a couple of days max. If you are seeing that your branches live longer than that, then you either have to break up your issue into smaller compartments, yeah, and kind of revisit that. So basically, once you branch off a master, develop your feature, then you have to test it out. And this can be done via, it could be a manual test. It could be an automated test, like on your, with your CI tool of your choice. But that's something that you want to do. We also require that, or the trunk-based development workflow requires that you create a pull request for your branch. That way you can get eyes on it, as well as trigger any automated CI tests. So then, yeah, there's a second point. So any new branches that we have will be merged back into master after a pull request is opened. And the new functionality that we define in there passes any build automation and tests. So now that we kind of know what we have to do, like let's visualize. Oh, sorry, that's the next slide. So I kind of wanted to talk a bit more about pull requests because I think they're extremely important. So, pull requests are one of the more popular code review models today, especially in the development of open source projects. So simply put, pull requests are one or more commits accompanied by text that describes functionality included in the commits. So they enable what's known as continuous code review. So basically, this is a process where a team is able to provide feedback on proposed commits to the trunk very quickly. So in the trunk-based development workflow, the first thing that we encourage developers to do to satisfy this process is have them open up a PR of their branch. So we want them to do this as early in the development process as possible. The code doesn't have to work, the functionality doesn't have to be there. The whole point of this is to get more eyes on the code as quickly as possible because more eyes means better quality code, and hoarding code is a no-no. It's just bad practice. So in addition to validation by our peers, we can also hook up our CI pipelines to our pull requests. So any subsequent commits to the PR will trigger any automated builds or tests that we require. So pull requests are a great part of the trunk-based development workflow. Cool. So now that we got pull requests down and we talked a bit about the feature development process, let's actually look at the process. So at the beginning, let's say we have our master branch. If a developer wants to create a new feature, he or she will create a branch. In this case, the name is branch 1. He or she will create a commit. Then we encourage them to open up a PR early. So at this point in time, now other developers have eyes on it, and we can trigger any automated testing or builds that we want with our CI tool of choice. I have a Jenkins icon here. I'm not a huge fan of Jenkins, but I know it's a popular CI tool. Any CI tool will do. But after running our automated tests and builds, one of two things will happen. One, the test or the build fails. So at this point in time, the developer has to go back to the drawing board, figure out what's wrong, and then push up another commit. Or the developer has decided that he or she wants to split up her feature into a couple commits. So if that's the case, she'll put a work in progress, say, hey, I'm just working on this. So yeah, that's that. So let's say he or she pushes up another commit, triggers the same process again. Again, it's either the build fails or the developer wants to, again, maybe add an additional commit. And eventually, we'll push up a commit that either finishes up the feature or now the builds are passing. So at this point in time, everything's vetted out. Then we can merge our branch back into master. It's important that we then, okay, cool. So I was gonna say, you can test master at this point to verify that everything works, but if this is like the first branch being created, it doesn't really matter. But as we can see here, the same process will happen over and over again. And this is the basic development process. Yeah, sorry, I think the animations are a tad slow, but yeah, same thing. Another branch is created for another feature. Once tests pass and the developer is satisfied with the functionality, then you merge that second feature back into the master. And at the end of, let's say, a sprint or a specified period of time, then you just test the master is deployable because it should always be deployable. And we'll see later that we actually create a release branch off of master, where we start the process of walking our functionality to a more stable environments. It's important that the branch off of master works, right? We want to make sure master actually works. So testing master is also very important. Cool. So, we're working in a team setting here. So you're going to run into situations where we have branches that, on which team members are working on that are merged into master before or while our branch still lives. So, our team members' branches may they're either created at the same time as ours or after the fact. But basically, once they're merged into master, that means that master now has a different commit history than our new branch, right? So that's bad, and we want to make sure that our new branch and master are always in sync for a couple of reasons. One, the functionality that we're developing can potentially break any new functionality that was introduced by our teammates' branches. Or two, kind of like the reverse of that, any new functionality that's been introduced into master could potentially break ours. So once we kind of sync up with master, we have to run any new tests to verify that everything works as expected. And if things are broken, then we have to go back to the drawing board, but figure out what's wrong, and then run tests again. So we basically get this syncing to happen with something called a Git rebase. And basically rebasing in Git allows us to temporarily remove any commits on our branch, and then apply missing commits from a branch of our choice onto our branch, and then puts our commits on top of that. So basically we take off our commits, we plop master's commits on our branch, and then we put our commits on top of that. So now our commits should work with the existing commits on master. So we're going to constantly need to be doing this because of the fact that trunk-based development has us iterating off of master. We're constantly going to have to be aware of the fact that there are other developers that are adding new functionality to master on a pretty frequent basis. So Denilson asked a question: any recommendations on coordinating permanent branches to the server-based tags? I have released something with tag 1.0 to 2. Should I have a trunk branch named 1.0 to service release 1.0? Great question.
Sorry, yeah, I mistyped it, sir, but I meant semver. I'm sorry. Yeah, the semver tags, you mentioned the 3 digits.
Gotcha. Cool. Yeah, that's a great question. So that's actually going to be answered very soon. But yeah, that'll be answered in a sec. We're going to get to the release process in the next couple of slides. But yeah, so kind of going back, we're constantly updating our branch with master via Git rebase. And it's going to happen. You are going to experience merge conflicts. Sometimes it's kind of unavoidable for developers not to touch each other's code or like the same portion of our code base. So expect those and deal with them as they come. We're not really going to talk about merge conflicts too much, but basically it's when two developers touch the same part of the code and then Git doesn't really know which change to use. So it says, hey, can you tell me which one to use? And you get to choose which version of the code you want to keep. Cool. So I actually have a little animation here to kind of describe and visualize this workflow. So again, we have our master branch. We create a new branch for that feature. Boom, commit. So at the same time, our developer number 2 creates another branch for another feature that they're working on. So at this point in time, we're kind of iterating in parallel, but developer 1 tests all his or her features, merges it back into master. So now branch 2 has different commit history from master. So what's going to happen is we're going to rebase master onto branch number 2. So what that does is it places all of master's commits under any commits that we have created in our branch 2. So that moves the starting point of branch 2 from like that initial commit to the latest commit at master. So basically now branch 2 has everything, all the commits included in branch 1, and we can then merge it back into master. So that's the general workflow. There is one thing I am leaving out here, and I go over it in this slide. So I'm assuming that you have access to the master branch. So this is kind of a little caveat. So if you are like, let's say, iterating on a forked repository, then the process is a little different. But basically, you're going to want to, so the step in between is basically getting what's located in your remote master onto your local master branch. So that's the step that I didn't go over, but basically the workflow is check out your master branch that's on your local computer, pull the latest changes from the remote master, then check out to your branch on your local computer, and then rebase the local master changes onto your new branch. And basically, this is the general workflow that we follow for trunk-based development. Cool. So now on to releases. So we're going to answer Denilson's question here. So the release process is comprised of two parts. So one, we create a release branch, and two, we then cut a release tag. So we're first going to talk about or discuss the release branches. So if you recall, a branch is just a reference to a specific commit in your repository. So kind of going off that, release branches are cut from commits that we deem as stable or viable, and that we want to begin leveraging in our more stable environments. So if you notice on the presentation, I put stable in quotations because branches are mutable and you can change the commits in which they reference. You can just push a commit to branch and then it's basically changed. However, you can definitely lock down branches and do things like that. So it's also important that your team is on board with this process. So at this point in time, when the release candidate branch is branched from master, at a commit that you guys are okay with, it should not be touched, and it should never be merged back into master. The only way you can actually get new functionality or commit onto your release candidate branch is via something called a hotfix, which we're going to talk about in a sec. But given this stable nature and assuming everyone is on the same page about when to modify and how to modify a release candidate branch, they are relatively stable, and this is where we can deploy and reference these the code in these branches in our more stable environments like staging. But staging can still it can still tolerate some volatility and some change. But this is great because the fact that the branches are still mutable means that we can push the necessary changes or fixes that we need. So this bullet here, release candidate branches allow master to keep moving forward. So this is great because as soon as we cut a release candidate branch, the master or the trunk is moving forward. Developers are committing to it at full speed. Everything keeps on changing. So the release candidate branch is just, it references a specific point in time with which we're paid to, to leverage. Git diff. You mentioned about git diff because it can show different versions. Yeah, so that's true. Okay, so there is something called git diff, and you can leverage this on multiple, Git objects like specific commits, files, as well as branches. So if you say git diff master space origin / master, it'll show you the difference between your local master branch and the remote master branch. And again, if you do a git diff on a file within your repository that's been changed, it'll show you exactly what has been changed in that. Does that answer your question, Fuak? Fuak? Sorry, how do you pronounce your name? Fuak. Yeah. Cool. All right. So the second, cool. So the second part of the release process is release tags. So you may have noticed that this slide looks a little similar to the previous slide, and that's because release tags are cut from release candidate branches. So tag creation is usually done a bit after the creation of the release branch. We usually want to test the code contained in the release candidate branch in staging and vet it out and make sure that everything does work as expected, because sometimes bugs do pop up, and we're going to be talking about that in a sec. But after we've given it some time to simmer and play out, then we can cut its release tag and have our even more stable environments leverage that. So environments like production. And if you recall, I mentioned in the past, tags are conventionally immutable. So I have to start putting them in quotations. But yeah, they're great for production. As long as your team is on the same page, in that you should never modify a tag or recreate a tag. Basically, once a tag is cut, it stays there forever or until you decide to delete it. But if you need to add new functionality and get it out to production, you need to cut a new tag. So we're actually going to talk about this release process and kind of putting the two together in the next slide. So I guess similar to release candidate branches, release tags also let us reference a specific point in time, so the master branch can keep moving forward. Cool. So here's the release process at a high level. We have a master branch. Let's say during a specific point in time, arbitrary, like a sprint, we want to develop n amount of features, and we have some functionality we want to develop. So we develop that functionality. So this functionality is developed over 3 branches. So we've introduced 3 new features. So we create the branches, merge them back into master. So at the end of our first sprint, we have 3 features. So we deploy master to verify that everything works as expected. And if everything looks a-okay, then we cut a release candidate branch. So at this point in time, this release candidate branch, and we call it 0.1.0, is the same as master, and it contains all the commits up until this point. So after running some tests and verifying that the code in the release candidate branch actually works as expected, we cut a tag for it. So after that, we have our second sprint. We want to add 3 more features. So we should create 3 more branches for that, for those features. And then at the end of the sprint, we deploy master again, test it, vet it out. If everything works as expected, we cut a second release candidate branch. And after additional testing, and once we're confident that the code in release candidate 0.2.0, that branch works, we cut the tag. So this is the general process, and it keeps going over and over again. And this is like a periodic release, but we also have to be able to, I guess, account for more ad hoc releases. So, in the event that there's a bug or some functionality we need to get into production as soon as possible, that's when we leverage something called a hotfix. So hotfixes are used to fix bugs in releases and get needed functionality into a release or production ASAP. So here's a visualization of the release process, but taking into account a more ad hoc release caused by bugs, or caused by a bug where we need a hotfix. So again, we have our first sprint, we develop some new functionality, 3 new features, everything looks good. We deploy master to make sure it's good. Then we cut a release candidate branch 0.1.0. So at this point, we test out our branch in staging, verify that it works as expected, cut a tag. Cool. So we've seen this before. Life's good. We're iterating quick. Got feature 4 here. However, there's a bug now. We experienced a bug in production. It didn't show up until this point in time, but things are not working as they should. So what do we do? So what we want to do is we want to perform the hotfix. So it follows the same steps or the same process as a regular feature or developing a regular feature, except this feature is needed to fix something. So in this case, we branch out. So we create a branch, B5, we call it B5 hotfix. We make sure that we can replicate the bug in production. Not production, sorry, on the master branch and our branch 5. We create the necessary functionality, make sure that our functionality, destroys the bug and everything works as it should. And then once we are good with that, we test out master, looks good. Then we cherry pick the merge of commits or the commit or commits that make up the hotfix. So it's important that we cherry pick the commits for several reasons. So one, if we were to merge all of the commits, so even commits that were part of branch 4, or introduced in branch 4, then we're introducing a lot of new commits that could potentially have even more bugs. So we want to get the minimal amount of new commits into our release. That way we can avoid, having another bug. And this hotfix process also gives us the ability to add new functionality to production after the fact, and it places some pretty good guardrails in place. That way we can limit hiccups, the amount of hiccups we run into. And I will state that this whole process, this diagram is a little higher level, but again, each of these features, the release candidate branch, the tag, like they're all running the same tests and like that same process that we saw when we first, in the previous slides, the developing functionality slide. So now that this commit that includes the fix has been cherry picked into our release candidate branch 0.1.0, we test out the release candidate branch again, make sure everything works as expected. And once we can verify, then we create a new tag from the same release candidate branch. So I think that answers your question, Denilson. So basically, the release candidate branch is long living, and we have the ability to cherry pick commits that fix potential bugs onto the release candidate branch, and then we create a new tag from the release candidate branch at this specific point in time. Was that what you were getting at?
Yes, that explains very well. And would you fix that bug? A question on a D5. Mm-hmm. Would you fix on the release candidate branch or on the master branch first?
Yeah. So right. So basically, we just want to make sure that. So I guess the first step here is to verify that we can reproduce the bug on master, just to make sure it's there. Then once we verify that, we create a branch for it. So that hotfix branch is used to develop like the fix. So in this case, we follow the same trunk-based development process of like branching off a master, right? It's the same thing, like any other feature. And then there, we fix the bug, we verify that it has been fixed, and we merge that functionality back into master. Then we might run one more test. Yeah, so we might run one more test to kind of verify that it has been fixed. And then once like we're completely sure, then we cherry pick those specific commits that contain the fix into our release candidate branch. And to answer that other point that you just made, you don't really want to fix the bug on the release candidate branch and then merge that into master. Just because if you do forget to merge it, or it doesn't, like the merge doesn't go through, then you're kind of adding regression. You're potentially, missing up other functionality and releases like somewhere along the line, because the fix never made it into master. So it's safer and better to, again, branch off master, fix the issue, merge it back in, verify that it's fixed, and then cherry pick. That's kind of the basic process. And then, after everything is like good and all's right in the world, we just add another feature, and then the process continues over and over again. So this is the basic release process. Cool. So I'm basically coming to the end of my presentation, but I wanted to end with kind of summarizing the benefits that you get from leveraging trunk-based development. So one is increased development frequency. So since trunk-based development advocates for short-lived feature branches, this characteristic is great for two main reasons. So one, it saves us the headache of, or I guess more importantly, the time wasted when trying to integrate long-lived feature branch. So the longer branch is alive, the more drift occurs, the more drift that occurs between like the source branch and that feature branch. So it's a pain sometimes when they diverge so much that it's merge conflict hell and things are not working as they should. So keeping the branches short-lived will ensure that our new branch never deviates too far off of master, and it doesn't complicate the process of merging it back in. And secondly, having shorter branches or short branch lives means that functionality that is encapsulated on this new branch that we're developing on is usually smaller. So this means, one, that testing is done more frequently. It also means that since there are less things to test, that means there are less things to debug, or less likelihood of bugs. So we're able to cut releases and release candidate branches more often. So that means that leads to an increased deployment frequency. In addition, at least like the mainstream, prominent flavor of trunk-based development, enforces this hotfix process, which is great because it definitely limits the likelihood of bugs or unwanted behavior making their way into your environments. And the fact that the process of like hotfixing and getting new functionality from master or your development environment to your release content branches and eventually your tags is only like 2 branches, means that there aren't too many steps when compared to other branching strategies that are they have like 3 long-lived branches. You got like develop, feature, like master, stuff like that, like Git flow. So it's definitely simpler in that respect. And lastly, increased collaboration and transparency of work in progress. So this workflow facilitates communication between team members via the code base. Since all changes are incorporated together in master, that means that all developers have to be aware like constantly of new functionality that is being merged, which means that they see all PRs that are coming through, and they're more in tune with what's going on. So in addition, the fact that I guess the common flavor of trunk-based development advocates for a PR-based workflow. This means that you have more eyes on the code, which is great early on, and this also allows you to enforce certain, I guess, team. What's what I'm looking for? Certain necessary requirements, such as having more than 2 people approve your pull request, or hooking up, your CI tooling, your CI pipelines to your PR. So it definitely increases transparency of work in progress. And again, like I found, at least at Nebulaworks, we found this workflow to work really well when iterating on infrastructure and like developing platforms. And it allows for very quick development time. So yeah, thank you guys for listening in. If you guys want to kind of putting a plug here, but if you guys want to learn more about this stuff and read up on some pretty cool, I guess, content, then you guys can kind of visit this Nebulaworks link here. We have a DevOps Wire where we, I guess, maybe like bi-weekly, we review and comment on relevant articles about various like technology topics, stuff like that. And if you guys want to learn more about trunk-based development, this trunk-based development website is very good, and they go very in depth on all of the best practices and how it should be used in production, things like that. Cool. So thank you guys.
Awesome.
Yeah.
Thank you, Matt.
So, thank you guys. And if you guys have any questions, I guess Folk has one more. So Folk, we do not use Jenkins that much. I will say though that a lot of our enterprise customers do leverage Jenkins, so it is very popular, and I still think it is kind of like the industry standard. But yeah, I think we use like, I guess, GitLab's native CI tool internally, and then I've used Drone, which I kind of liked. That was kind of cool. I'm not sure if Drew want to chime in there. If any, like, do you have any CI tools you prefer?
It's really just whatever the scenario is. So we've used Azure DevOps, we've used Circle, Travis, Jenkins.
Gotcha. Yeah, I've heard good things about Azure DevOps recently. It's supposed to be pretty good.
Yeah, surprising, but
yeah,
true.
Right?